Alright, you are welcome to today's class. My name is Mr. Emmanuel. So for today's class, we're looking at stoichiometry, what some authors call mass-volume relationship. Mass-volume relationship. So you might be wondering what we mean by this stoichiometry in chemistry. Even this morning now, I don't know if you must have cooked, if you still cook by the end of the day. As we cook in the kitchen, we prepare food in the kitchen, we involve what we call stoichiometry without even knowing. For instance, let's look at a situation where in a family of 4, each of us we consume 1 cup of rice. If you are to prepare food for us, how many cups do you think you are going to prepare? I repeat, in a family of 4, each of us will eat 1 cup of rice. How many cups do you think you are going to prepare? Definitely, you are going to prepare 4 cups. You have just involved stoichiometry without knowing. So, food producers, cooks, all of us involve stoichiometry without knowing. So, what is this stoichiometry of a reaction? It's a reaction. Stoichiometry of a reaction is the mole ratio in which reactants combine and products are formed. It gives you that relationship between the reactants and the products. So we are going to look at stoichiometric problems. In stoichiometric problems, you have mole calculation, mole mass calculation, mass volume calculation, and at the end we have a volume to volume calculation. Mole calculation, we mean that the amount of the reactant is in moles, and also the amount of the product formed is also in moles. Mole to mass calculation, the reactants is in moles while the product is in a mass, or vice versa. That is to say, the reactant can be in mass while the product can be in a mole. Mass volume relationship, the reactant might be measured in mass while the product is measured in a volume, or vice versa. Talk about volume. The reactant and the product is measured in a volume. So, when we have this reaction, A plus B will give us AB2. For example, the reactant A is coming here is 1 mole, while reactant B is 2 moles, while the product AB is 1 mole. You can see the relationship between A and the product is 1:1. 1 mole of A gives us 1 mole of AB. That is A towards AB. 1:1. In the other way, you can also have B towards AB. You can also relate B and B to the product AB2. It's 2 moles of B we need to produce 1 mole of what? AB2. So the stoichiometry here is that we are using 2 moles of B to produce 1 mole of AB2. And the stoichiometry here is that we are using 1 mole of A to produce 1 mole of AB2. So from here we may ask, if 1 mole of AB is needed to produce 1 mole of AB, how many moles of AB2 will be produced if we are using 2 moles of AB, 2 moles of A? I repeat, the stoichiometry here is that 1 mole of AB is needed to produce 1 mole of AB2. So the problem we need to solve here is that how many moles of AB2 will be produced if 2 moles of A are used. So here you can see it's 1:1. Definitely we'll be producing the equivalent amount of 2 moles of AB2. So there's no more problem when we talk about mole calculation. So we are going to look more details in mole mass calculation. Like I said previously, in the mole mass calculation, the reactant might be measured in mole or mass, or the product is measured in mole or mass. Steps involving solving problems involving mole mass calculation, mole mass relationship. Step 1. Write a balanced chemical equation for that problem. Write the amount in moles under each of the relevant reactants and products. Step 3. Convert the amount to mass as required by the question. Then finally answer the given question. So let's look at example under that problem. Example 1. Calculate the number of moles of calcium chloride. The number of moles of calcium chloride that will be obtained from 50 grams of limestone in the presence of excess hydrochloric acid. The relative atomic masses of the elements involved are calcium equal to 40, carbon equal to 12, oxygen equal to 16, hydrogen equal to 1, chlorine equal to 35.5. We need to write the balanced chemical equation for that. Solution.
Solution, please don't be offended.
As step 1, write a balanced chemical equation for the problem. Here we can see from the question that calcium chloride, calculate the number of moles of calcium chloride that will be obtained, meaning the calcium chloride is in the product side, from 50 grams of limestone, calcium carbonate, in the presence of excess hydrochloric acid. Means that the calcium carbonate and the hydrochloric acid are the reactants. So we have CaCO3 plus HCl will give us CaCl2 plus carbon dioxide and water. When we balance the given equation, we are going to add 2 in front of HCl. From here, we have obeyed the first one, who says write a balanced chemical equation for the problem. Now, the second step is write the amount in moles under each of the relevant reactants or products. Now, what is the relevant reactant or product in this given problem? Let me repeat the question. Calculate the number of moles of calcium chloride, which means calcium chloride is the relevant product here. Then, that can be obtained from 50 grams of limestone, meaning limestone is a relevant reactant. So meaning the HCl, which is part of the reactant, is not our concern. The carbon dioxide, which is the part of the product, is not our concern. Even water is not also our concern. Our concern here is the calcium chloride and the calcium carbonate. Now, write the amount in moles under each of the relevant reactant. The relevant reactant here is calcium carbonate. What is the amount in moles? 1 mole. From here, 1 mole. That will give us 1 mole of calcium chloride. Now remember that this problem is a mole mass problem. So it means one of them will be converted to mass using molar mass. So you need to find out the one we are converting to mass and the one we are still going to leave at the mole point. So calculate the number of moles of calcium chloride, meaning calcium chloride we are looking for is moles, we are not converting to mass. While 50 grams of the limestone has been given, meaning we are going to convert this 1 mole to 50 grams. That is step 3. Convert the amount to mass as required by the question. The calcium chloride will remain as moles, while the calcium carbonate will need to be converted to mass. Now, by converting this 1 mole to mass, when you work on the molar mass of calcium carbonate, the molar mass of calcium carbonate is 100 gram per mole. 40 for calcium, relative atomic masses are calcium 40, carbon 12, oxygen 16. 16 times 3, which is the number of atoms of oxygen there. That will give you 100. Confirm if we are correct. Confirm if we are correct. Confirm that. So that will give you 100 grams per mole for the molar mass of calcium carbonate. So from here, in every 1 mole of calcium carbonate, there is 100 grams. So here, 100 grams of this calcium carbonate equal to 1 mole of calcium chloride. Calcium chloride will maintain mole because the question is a mole. while the calcium carbonate is moving to mass because the question is talking about mass, 50 grams has been given. So this is the statement according to the balanced chemical equation. According to the balanced chemical equation. Now we need to go to the last step, which is answer the question. Then what is the question? The question says, how many moles of calcium chloride that we obtain if you provide 50 grams of this calcium carbonate? From the balance equation, we can see that 1 mole of calcium chloride will be obtained when 100 grams is used. Now, if we are using 50 grams of calcium carbonate, what will be the amount in moles produced? So we say X mole of calcium chloride. From the question, 50 grams of calcium chloride will now give us S mole of calcium chloride. Because we multiply, make X is subject to the formula. We have 50 times 1 all over 100. That will give us 50 over 100. That will give us 0.5 moles of calcium chloride. It's as simple as that. So, from what we are saying here is that from the balance equation, we can see the relationship between calcium carbonate and calcium chloride. That 1 mole of calcium chloride is needed to produce 1 mole of calcium carbonate is needed to produce 1 mole of calcium chloride. It's needed to produce 1 mole of calcium chloride. It's needed to produce 1 mole of calcium chloride. Here the question, the unit in the question is talking about mass and mole. For the mass, the calcium chloride was given as 50 grams, while the calcium carbonate was given as 50 grams, while the calcium chloride was still needed in moles. So this statement here represents the balanced chemical equation. 100 grams coming from molar mass of calcium carbonate gives us 1 mole of calcium chloride. As presented in the balanced chemical equation. Then we need to go ahead to the last question to answer the given question. And the given question is how many moles of the calcium chloride will be obtained from 50 grams of limestone. For 50 grams of limestone. So here, these are the established facts of the balanced chemical equation. That 100 grams of calcium carbonate is giving us 1 mole of calcium chloride. So here is the question: 50 grams of calcium carbonate will not be giving us X mole of calcium chloride. So we make X the subject of the formula, solve, and we get 0.5 moles of calcium chloride. With that, we have succeeded in solving the mole mass relation. Understand? A follow-up question will come to check your knowledge. Thank you. We'll see you some other time.